Hello, I'm very happy to be breaking the wall for Arctic ice and also climate research and our big quest to bring the two together. Just imagine for a moment you'd be a polar scientist, then you would deal with these fantastic landscapes of whiteness, the North Pole, the South Pole, and also the changes that have occurred in Earth system history, but that are occurring now at an unprecedented time and space and velocity. Look at these pictures and you understand immediately how ice can change and transform by melting. When the white melts and is replaced by dark ocean, it will absorb more sunlight, it will warm faster, and it will change the habitat, the ecosystem, the food web for many endemic species. For life that is important to us, for life that has been there long before us. And today we know that there is a direct link between our behavior in terms of greenhouse gas emissions and the fate of the Arctic sea ice as one of the key sentinels of Earth system changes. Here you see on the left side a map of Arctic sea ice extent. We can measure this by satellite, and you can see the last 2 years of sea ice minimum. Almost every year is another minimum of any kind. Right now, we just had the largest autumn sea ice minimum of all time since the onset of human observation. You can see the trend in sea ice decline. You can see it is 13% per decade, and by knowing this trend, we can predict when there will be a time when in summertime there will be no more sea ice. We can also use our climate models to predict the link between CO2 emission and sea ice, and as it turns out, it is something like a metric ton of CO2 will shrink summerly sea ice by 3 square meters. So you can even calculate what a flight to New York and back means for the space that polar bears have. What is an important new message, an important new understanding of the relationship between CO2 emissions, warming, and the cryosphere is that we can calculate the space our atmosphere has for more CO2 until we will reach certain tipping points in the Earth system that we can discuss and look at from the perspective of past Earth system states. I will show you this real quickly. Now, imagine yourself in Antarctica drilling a core into kilometers thick ice sheets. Those ice sheets are made from snow falling and freezing little air bubbles. We can take this core and we can suck out the tiny air bubbles and we can measure CO2 of the past. And you see here in this graph, you can travel back 800,000 years before today, when there were animals on the planet that we would call humans, the onset of human society, our attempts to play with fire and ice. And you can see there was a dynamic in CO2 concentrations in the atmosphere. And then on the right side, what we call the zero time, you see in red where industrial revolution brought us today. We have now more than 400 parts per million of CO2 in the atmosphere, and you can see for the entire evolution of humanity, for our civilization globally, there was no such time with that much CO2 in the atmosphere. We as scientists can travel further back. We can use marine sediments, lake sediments to go back even further. Millions of years. We have to go back to 2-3 million years ago to find an Earth system state with 400 parts per million of CO2. But in that time, sea level was 10-20 meters more than it is today. The cryosphere was tiny. So bringing these informations together, now one of the biggest missions for polar and Earth system scientists is understanding the acceleration of change in the cryosphere. We are coming together internationally, comparing our climate and Earth system models, and we understand that we have not included enough polar knowledge. The polar change of Earth seems a mystery. The connection between Arctica and Antarctica and us is something to be explored. That's knowledge that seems to have walls that we need to tear down. Here you see the observed change of temperature. It's just observed. No one doubts that we can measure temperature, right? And that's what we have measured. You can see that the northern hemisphere, the Arctic, has accelerated warming 2-3 times faster than the global average. You can also see in the orange color that we have already reached 1.5 increase in global land temperature. That's the goal that we have for our future. So this graph that was just published during the Climate Action Week in New York 2 months ago is, to me, a secret that links the past, the present, and the future. What you see now is in orange the path we're on, the warming path humanity is on. In gray, you see the observed temperature. Again, no one in this room will doubt that we can measure temperature. And you can see that there is huge of deviations, changes, annual decadal changes. You can see in the past years, we went beyond the limits of certainty that we think our models produce. Now look into the future. The path we don't want to be on is the orange path. That means that in a few decades, we will pass the 2-degree goal that we have marked, because that's a tipping point in the Earth system where things happen like meltdown of ice sheets, of glaciers, of sea ice. So we want it differently, but that means that we have to turn the energy system that consists of 80% fossil fuel usage to something else, a huge mission. And science is needed to manage that mission. All science is needed to manage it, but I'm sticking to my science, Earth system science. Here you see another graph that tells you how we have to break the wall for Arctic ice and much more for all Earth system states that we're in now and in the future. You see a projected warming until the end of the century, and you can look at all latitudes together from the South Pole to the North Pole. You can see that the 2-degree temperature change goal that we're after, you can see it in blue, and you can see that when we move to our latitudes, 60 degrees north to the North Pole, then the uncertainties increase tremendously, again for the reason that we do not have enough observations that are physical, mechanical causes and consequences that we don't know of. And why is that so? Because we are not enough out there. We have no human presence, almost no human presence in the central Arctic Ocean, and hardly one in Antarctica, in those places where things are changing very fast. Just as one example, the northernmost weather station that we have on Spitzbergen, where the Alfred Wegener Institute and the IPEF of France have a research station together, we have found out that winter is warming much faster than the average, but we cannot really simulate and explain that well. So questions like this have made us make the largest polar mission ever in human history. It's ongoing right now. You may have heard before about MOSAiC, a giant international science mission to have people on board of our research vessel, the icebreaker Polarstern, a more than 30-year-old lady of a ship that needs replacement soon. And that ship is frozen in. It's about 200 miles away from the North Pole, and if we're lucky, we will in a moment connect to the ship and to its chief expedition leader. This image shows you what we have to do. We have to understand the polar night when there is no light, very few photons except the photons we make or live in the Arctic and the sea ice makes. The last one to make the largest polar mission ever was Fridtjof Nansen 126 years ago. In fact, he's the only other human besides brave Russian scientists who managed to drift for long times to the ice and explore what winter means. The questions for Fridtjof Nansen were, is the Arctic Ocean really an ocean or is there a hidden continent? It was him to measure the depths of the Arctic Ocean and find out that it's deeper than the wire was that he had on board. We have 5 kilometers depth in the Arctic Ocean. There is no continent. It's an ocean with ice on top, and the ice is melting away. It's so thin that we cannot put any more people in tents out there without a ship that will carry them when the ice breaks. And this is exactly what we're doing. Polarstern is out there. And we have just launched on the 20th of September the largest international polar expedition ever. And I was there, some people in the room were there, and you know this special feeling when you wave goodbye to 100 people who are on this mission. They will be exchanged every 3 months, and the feeling of working together globally, Russia, our strongest ally in that mission, China, another strong ally. Sweden, they have icebreakers. They can bring people forth and back. They helped us finding the right ice. We have planes and helicopters. It's more than 60 institutions and by now even more than 90 nations cooperating for one mission, solving the mystery, the secret of the polar night in the Arctic. What are we doing? The ship is frozen in, it found its ice floe. It has a central observatory that is Polarstern. It gives some energy to networks of observations around it. There are aircrafts that are broaden our view on the ice, and there are the icebreakers that bring people forth and back. The mission, the planning of the mission started in 2011 when clever atmospheric scientists in Potsdam connected to their colleagues and they decided, let's build a vast mission, let's bring everyone together, let's form teams of scientists that work together, calibrate their instruments, and we did that now. It's 7 years of preparation for each of these processes, the coupling between clouds and ocean, the atmosphere, sea, ice and snow, the ecosystems. There were crowds of scientists from various cultures bringing together knowledge and expertise in measurement, standardization, data flow, so that we can, for an entire year, for the first time in human history, complete that mission and have data and knowledge forever. Data that helps us solving the big question of what's the future for the Arctic, for the Antarctic and us. And let's now try to connect to Polarstern. We are 300 miles off the North Pole. You see the pictures of the people building the observatories out there. They have completed the mission. The observatories, the observation cities are now built. It's quite tough because it seems that we've just caught the last ice floe of a 2-kilometer diameter and of a thickness that would hold our observatories for more than a year. And now, let's try to contact the chief scientist on board. Markus?
Antje, I can hear you very well. Greetings to Berlin from Polarstern here in the Central Arctic.
So Markus, let us know, what do you see right now? Where are you right now?
Yeah, I'm here in my office on the vessel. We are at 86 degrees north and 116 degrees east, just 400 kilometers from the North Pole. And as you probably would expect, in front of my window, it's dark. We are in polar night, which lasts several months up here. But in the dark, we still see the ice of the Central Arctic. It's still a mix of flat areas, weird shapes made out of ice, formed by the forces of ice pressure and wind. And actually, right now, on our starboard side, I can also see a polar bear wandering through the night and checking out what we are doing up here.
Okay, be careful, Markus. So what is the wall that you had to tear down? What was so far the biggest issue for getting this mission together?
Yeah, we will make sure that we don't approach that polar bear. Everybody is safely on board. You can rest assured there. These walls, these are the walls between our scientific disciplines and our countries and cultures. 19 countries take part in this truly international and interdisciplinary expedition. And it is fantastic to see how efficiently we work together under these challenging conditions up here. And I think it is an example of how countries can and actually should work together on the last frontiers of our world.
Thank you. And what is your big hope for this mission? What's the hope that you have to bring home?
This is to bring back everybody safely and to break our biggest wall, to unlock the secret of the Arctic climate system.
Thank you, Markus. Greetings to everyone. And so, besides the exciting scientists that we do together with this crowd of people from all the different places, we have also decided of trying a scientific mission that connects us all. Simply, as you said, the moonshot, the first steps on the moon. How did this change the feeling of our people and the way we think about science? So explorations, missions to the functioning of our Earth system that sometimes appears as a foreign, as a strange planet, that's the purpose of this big mission. And the communication that we have chosen to carry out is connectivity. So we have an app that everyone can follow, the mission, that you every day see images, you see through the eyes of the scientists out there. You can read their blogs, you can read what they see, and we are daring to show also the risk of such a mission. As Marcus said, they're polar bears, they're hungry. So they are sitting next to the gangway waiting for physical scientists to step down and go measure how thick the ice is that remains. No, really, we are prepared for this, of course. We are in the home of the polar bear. We are trying to understand what their future is. And so we are really trying together. It's very cold out there. We are trying to bring this knowledge together to the homes, connect everyone, let everyone be part of this big expedition. So cross fingers for us that polar bears and people all have a safe future. Thank you.